right? So let's talk about the series. Let's just say that we have, so let's go ahead and jump right into an example. Let's say that we have a series circuit that looks like this, okay? So this guy here is a voltage. This represents a voltage. This is the positive, this is the negative, okay? So the current's going to flow from here this way, okay, right? So the current flows from here to here, okay? Let's say that we had a 1 ohm, 2 ohm, and a 3 ohm resistor here, and we had a voltage of 12 volts, okay? And this is obviously a DC circuit here, right, okay? So this is a direct current, not AC, okay, all right? Because it has specific positive and negative, right? AC, you would not have a specific positive and negative because it alternates, right? It changes, and that's why it's called AC, alternating current, right? Okay, so this is direct, this is DC, okay? So it's gonna move this way, okay? So current's gonna come out this way, and it's gonna go through all these resistors and come back, okay? So the first thing that we need to determine here is what is the current? We need to determine what the current is, okay? So we have the volts, so we know that the current is going to be equal to voltage divided by the resistance. The question is that how do we determine the total resistance from the 1, 2, and the 3? Okay. If you go to page 412, it shows you on the equation there, 12.5, when they are in series, in this fashion, you just add them all together, and that is your total current, total resistance, right? So the total resistance here is going to be what? The total resistance is going to be 1 plus 2 plus 3, which is going to be 6 ohms. You have 6 ohms there, right? Okay, so you have 6 ohms. The current, therefore, the current is going to be the voltage divided by the total resistance, and the voltage was 12. So you have 12 divided by 6, which is 2 amps. So so through this, a 2 amp current is going to run through, okay? All right, so now, since I know that what the current is, and the current here is going to be the same as the current here, or here, or here, because there really is only one way for it to go, right? It can only go one way. There are no other places it can go, all right? So if the current here is going to be 2 amps, that means that the current here is going to be the same. This is going to be 2 amps, and this is going to be 2 amps. They're all going to be 2 amps, no matter where they are. Okay. So let's look at the voltage drop across this resistance, okay? So the voltage drop here, the V is going to be IR, right? And we know that the amperage was 2, and we know that the resistance here is 1, so which means that I'm going to see a 2-volt drop from here to here, from here to here. From here to here, I'm going to get V is equal to IR again, where I is still 2 amps, but now the resistance here is 2 amps. So I'm going to get 4 volts, okay? Over here, my voltage is going to be IR again, but it's 2 times 3 ohms, which is going to be 6 volts. So I started with 12, I lost 2 volts here, 4 volts here, and then 6 volts here, which makes sense. If you add them together, 2, 4, and 6, they're the total 12 volts here, okay? So this is how you would look at a series circuit, okay? A series circuit, all right? So just one thing of clarification, okay, is that, does anybody tell me which way the electrons are flowing? Electrons hold what charge?
Negative.
They're negatively charged, right? So within an atom, you have an atom here, you have the nucleus, and then you have an electron that's rolling around here, right? You have an electron that's orbiting that's around here. You have the negative electrons. What is the positive stuff in the nucleus? Anybody know what that is?
The protons.
Protons. You're going to have a proton here that has a positive charge. And that's what is they're trying to, that's what holds this together. Okay, so now, since I have electron as a negatively charged, if this is the negative plate, am I going to repel or attract?
Repel.
You're going to repel. So electron, actually, the electrons are going to flow this way from the negative plate to the positive plate. So the electron flow is actually directly opposite to the current flow. Okay? And that's a quirk of science because people discovered current before they discovered electrons. So, okay, they know that the current flow is this way, but they really didn't know what actually current flow is the flow of electrons, and electrons actually flow the other way around. Okay? Just a tidbit there for you guys. So let's see if we can do another one of these. Let's see if we can do. Let's see if we can do the example in the book. The book has I have 9 volts here, and I have 3, 7, and 9. 3, 7, and 9 ohms. Okay. Again, so very first thing we're going to do is going to try to determine the total current flow. We're going to find the current, right? So the current is going to be what? I is going to be equal to V over R, where V is the 9 volts. And the total resistance is what? How do I find the total resistance here? Ezekiel, how am I going to find the total resistance?
Isn't it the sum of all the resistors?
Yeah. So it's going to be what?
3, 9, 28? Wait, never mind. That's a different formula. That is a different formula.
3 plus 7 plus 9 is 19. Okay, so we're going to get 9 volts divided by 19 ohms. And if we do that, you're going to get approximately 0.5 amps, about half an amp, okay? So half an amp is going around here, okay? So the current flow is going to be half an amp, whether it's here or here or here, wherever it may be, okay? So if I were to ask you for the voltage drop again, voltage drop would be the 0.5 times the 3, so it would be 4.5 volts. Over here, the voltage drop is going to be 7 ohms times the half amp, so it's going to be 3.5 volts. Over here is going to be the voltage is going to be equal to 9 ohms times the half amp, so it's going to be 4.5. If I add these together, I get 9.
Isn't the top one like 1.5?
1.5. 1.5, so it'd be 6, 9.5. So we're a little off just because we approximated here, right? We're approximated here, okay?
Which example is this?
This is on page 413, 12.4. Another thing that I could possibly ask you is now, what is the power consumption across this guy? I can ask you what the power consumption is, right? What is W, right? W was equal to what? W was equal to VI, correct? So it's going to be this guy times this guy, right? The voltage drop across here was 0.5. 0.5 times that is going to be equal to 0.75 watts. Okay, the voltage, the power consumption over this guy is going to be the 0.5 amps times the voltage, which was 3.5, which is 1.75 watts. Same thing here, the wattage is going to be equal to the 0.5 amps times the voltage, 4.5. So it's going to be 2.25 watts. Okay, so yes, I could possibly ask you to calculate the power consumption across each of these guys also. Okay, all right. So let's go ahead and call it a day with that. And